All right, guys. So I just quickly wanted to go over a couple things with you that we've talked about this week. One of the things that we talked about is the idea of axis of symmetry. And we've talked about that on M32 or M532 and M533, okay? And we talked about it in the regard of axis of symmetry is x equals negative b over 2a. And I know some of you guys might have been confused about that, so I wanted to just show it to you guys one more time in regards to a couple functions that we've looked at over the course of the week. One is a pumpkin chunkin pattern in which we got an equation like this of negative 16t squared plus 128t plus 68. And we talked about the idea of finding out what a is. And we talked about ax squared plus bx plus c being standard form. So a would be negative 16. In this case, b would be 128. If we wanted to find the axis of symmetry when the equation's in standard form, we could do negative b over 2a. So in this case, we would just do x equals negative 128 over 2 times negative 16, which would be negative 128 over negative 32, and you guys would get the axis of symmetry to be 4. And if I look at this graph that corresponds to this, you guys would see that x equals 4 is your line of symmetry for the graph. Now I can also look at something that's in factored form, and that's what this one is. And I can identify what my intercepts are by just looking at factored form. And that's what factored form tells me. I could tell you that one of the x-intercepts is 17 over 2. So 17 over 2 is one of the x-intercepts. And then the other one would be, what would I have to do to get a plus 1/2? Well, we would say that an x-intercept of negative 1/2 would be the other one. So we're going to take, if we wanted to find it when it's in factored form, we can just add the two x-intercepts together and divide by 2. So just to kind of show you guys in this case, if I take 17 over 2 plus negative 1/2 over 2, I could get my axis of symmetry as well. So 17 over 2 plus negative 1/2 gets you x equals 8 over 2. And you guys would get the same thing that we had earlier, an axis of symmetry of 4. Okay? Just to look at one more example. In this case, let's start off with factored form, okay? All right, so I got x plus 10, x minus 50. Well, I know factored form is x minus r1, x minus r2, and r1 and r2 are your x-intercepts. So in this case, if I look at the minus 50, well, the first x-intercept would be 50, and my second, or my first one, depending on how you guys think about it, would be negative 10. Because if I do minus negative 10, I get plus 10. So if I take negative 10 plus 50 over 2, I would get my axis of symmetry, which would be 40 over 2, which is 20. And if I look at this graph, I would get my axis of symmetry to be 20. Now the reason why the axis of symmetry is important is because if I know what my axis of symmetry is, then I can find out what my vertex is. And if I wanted to find my vertex, all I have to do is plug axis of symmetry into the equation that we started off with. Okay? So I can use standard form, or I can use vertex form, or factored form if I wanted to find it. So if I do negative 10 times 20 squared plus 400 times 20 plus 5,000, I could find out what my equation is. So if I take negative 10
times 400 plus 8,000 plus 5,000. I would get it. So I'm just going to plug this into my handy dandy calculator. I would get 9,000 for my vertex. So my vertex would be, if I look at it graphically, my vertex would be at 29,000. So if I look at the graph, is this, I got 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, gets me my vertex. Okay. Hopefully that helps out, guys. I will see you